In this video, I'm going to go over example 1 for designing parabolas. So, we're given the quadratic function y equals x squared plus 6x plus 5, and we're asked to find the axis of symmetry. So using our formula, x equals negative b over 2a. Let's pick out negative b, so we consider a to be the one that's in front of x squared, b is the 6, and c is the 5. So that's what they're talking about when they say negative b over 2a. We need to say negative 6 over 2 times a, which is 1. And then we just have to clean that up, simplify a little bit. So negative 6 divided by 2, make that look a little better, equals negative 3. So our axis of symmetry is x equals negative 3. So what I'm going to do is go over to my graph, and I'm going to draw an imaginary line at x equals negative 3. That is going to be my axis of symmetry for my parabola. And then, to find the vertex, which is the next step, we're going to use this axis of symmetry we just found and plug it into our original function. So that's what this represents. F of negative b over 2a means to take what you found for x and plug it back in for x to figure out the y. So you're going to say y equals negative 3 squared plus 6 times negative 3 plus 5, and then simplify to find your y value. So negative 3 squared is 9 plus 6 times negative 3 is negative 18 plus 5. So keep simplifying. And you get 9 minus 18 is negative 9, plus 5 would be negative 4. So then you have your vertex. So your vertex is the negative 3 that you already found above there, and then the negative 4 that you just found y to equal. So that is our point that would be our vertex of our parabola. So go to negative 3, negative 4, and plot that point. And then, if we take a look at our original function, we're able to pick out the y-intercept pretty quickly because it's just equal to that c value, so that 5. And so, on our graph, this is going to help us out because it's not on the axis of symmetry. The y-intercept is at 5. Let's plot that point. So 1, 2, 3, 4, 5. And then using the idea that we have another point on the exact opposite side, because that's our axis of symmetry, so it means our parabola would be equal on both sides of that imaginary orange line. Then we're able to draw our parabola, which is a U-shaped curve that represents a quadratic function. Now the last part, so we've already done use the axis of symmetry to help us find that third point. That's what we did just a second ago. Let's just label the domain and the range. Pick out what those are. So domain of our graph is how far this graph goes left and right. So if you think about it, this graph with these arrows on here are going to go left and right forever. So we would say the domain of our quadratic function is all real numbers. So I can write it with that funny looking R, or I can put all real numbers in words. Your quadratic functions will always have that type of domain because the ones we work on are going to all have an upward facing U or a downward facing U. We don't do the ones with left and right in math too. So then the range, let me just grab another color. Range is how far your y values go on your graph. So notice the lowest y value of my graph is at negative 3. But then the graph goes up forever. So I would say that the range of my graph is that y has to be greater than or equal to negative 3. So this is all of example number 1.